Hey everyone, this is Mr. Sal. This is the practice test for Unit 9. I know we weren't able to go through it in class, so we're going to be looking at some of these problems, which are very similar to the ones on the test to help you guys out. So make sure you study these and prepare yourself for the test. Thanks for watching. Subscribe and comment below. This is the Unit 9 practice test, the first part. We'll go through these and notice on this first part it just wants us to figure out how many outcomes there are. We don't need to figure out any probabilities specifically. Alright, this has to do with compound probabilities, kind of. For example, if you're choosing, we got a drink first. You got water, milk, juice, or tea. And you can either get with ice or without ice. And then you can get it in a glass or plastic cup. Okay? So the first thing is we see that you have 4 choices of drink. And then you got 2 choices with either ice or without ice. And then you got 2 choices of cup. If you multiply these, this will tell you how many possible outcomes there are, which is 16 outcomes. Yeah, don't forget the label. Picking a number from 1 to 30 and a letter from the alphabet. So starting off on this, just with the letters, it appears that we have 30 total choices. And alright, 26 letters in the alphabet. So now to solve these, we're just going to multiply these two. 30 times 26, 780 outcomes. What is the probability of spinning a 2, then a 2 with this spinner, when spinning the spinner shown at the right twice? We're going to spin it twice. The first time needs to be a 2. And right here we have the 2. That's 1 2 out of 8 possible outcomes. On the second spin, it's the same 2, so there's still only 1 out of 8 possibilities. So this is a compound probability which we can just multiply, and it would be 1 out of 64. That would be the probability of spinning a 2, then a 2. Sienna tossed 10 heads when tossing a coin 24 times. What is that experimental probability of tossing heads? Well, she did toss 10 of them out of 24 total tosses. If we wanted to simplify this, we could just divide each by 2. And then we would get 5/12. And that's okay, we can just keep the fraction on this. The questions on a multiple choice test have 5 answer choices. Which of the following models could you use to simulate the outcome of guessing the correct answer? Alright, we need something to have 5 possible outcomes from one, activity. So spinning a spinner with 5 equal sections, that sounds like it works. Let's just check this. Flipping a coin 5 times, it gives you 5 outcomes. However, the problem with that is that there's only 2 total outcomes for the 5 flips, so that's not going to work. If it has 4 equal sections, then that also will not work. And then rolling a number cube labeled 1 through 6 5 times? No. I mean, you would do it 6 times, but the problem is there's 6 possible outcomes for each rolling. So on this one, it's just spinning a spinner with 5 equal sections, and that would tell you 1 possible outcome. Right? 1 outcome out of 5 possible outcomes. So on 11, we got to find the probability of a vowel. Let's just identify. On this spinner, there are 6 total spaces, or 6 outcomes. And how many of these are vowels? I got 1, 2. So 2/6. If you did simplify it, which is okay, you'd have 1/3. Find the probability of not D. So one of these spaces is D, right here. So the ones that are not D would be 5 of them. And that's out of, once again, 6 spaces. This can be simplified, so that's it right there. For exercises 1 through 3, use a spinner. What is the probability as a fraction in simplest form? It's the same spinner we were just looking at. So for D, there's only one space that's a D out of the 6 total spaces. A consonant is anything that's not a vowel. So we remember these, the A and the E are vowels, which means on this one we got 1, 2, 3, 4 spaces out of the 6 that are not vowels or that are consonants. And this could simplify to 2/3 as well. Either one works. Now finally, let's look at the probability of not A. Yeah, that's very good. 5 of the spaces are not A out of the 6 total spaces. Alright, so once again, we're looking at the total number of outcomes for each of these. So we're going to toss a coin. So that's 2 total outcomes. We're going to spin a spinner with 5 equal sections. That's 5 possible outcomes. 1 through 5. So we're just going to multiply these, and that gives us 10 outcomes. So to start off, the 2 number cubes have 6 sides. It's just a dice. So on the first roll, you got 6 possible outcomes. On the second one, you got 6 possible outcomes. We're just going to multiply these, and we could see that there would be 36 outcomes. So this one's similar to that last one that we did on the first couple problems there. So just to start off, you can either choose water, iced tea, lemonade. So that's 3 possible choices there. You can get lemon or lemon twist, which is 2. Or you can get it served in a small or large glass, which is also 2 choices. We're just going to multiply these, and whatever comes out is how many outcomes, and yes, it is 12. There are 7 clarinet players in the concert band. In how many ways can they be seated in 7 chairs at a concert? Alright, so let's just, maybe a picture will help us with these. So these would be the 7 chairs. We're just going to assume they'll sit in this way. Not that it really matters. I'm going to number these so we can keep track of which is which. We'll say this is chair number 1, 2, 3, 4, 5, 6, and 7. So we got 7 clarinet players. So if I look at seat 1, we're going to fill seat 1, then we'll fill seat 2, and so forth. Since there's 7 clarinet players in seat 1, I could put any one of 7 people into this seat.
So it would be like 7 times 7.
Now, in seat number 2, though, since I have one person seated in seat 1, I've only got 6 choices for seat 2. For seat 3, now that I've seated 2 people, I've only got 5 left to seat. For seat 4, now I've got 4 people to seat. 5 would be 3. 6 would be 2. And then 7, you have only 1 person remaining to sit. So to figure out how many ways we can seat these people, we're going to multiply these. And that tells us how many ways we can rearrange the clarinet players in 7 seats for 7 players. All it says is that they could rearrange the clarinet players in 5,040 ways for 7 seats and 7 players. The store is handing out coupons worth 30%, 35%, and 40% off. Each coupon is equally likely to be handed out. Which of the following models could be used to simulate these? So we've got 3 total coupons. 1, 2, 3. So to simulate it, we need something that will give us 3 possible outcomes. A coin does not do that. Rolling a number cube, labeling 1 through 6 3 times.
No.
No, that's not going to work either. H, spinning a spinner with 4 equal sections. Well, that's 4 equal sections, not 3, so that's not going to work either. Spinning a spinner with 3 equal sections. Yes, that would give us 3 possible outcomes right here. I. Vernon tossed a coin 20 times. The results were 8 heads and 12 tails. So what's the experimental probability of tossing heads? Well, he did get 8 heads out of 20 tosses. So if we were to simplify these, we would divide both of these by 4, and that would give us 2/5, which is B. What is the best comparison between the theoretical and experimental probabilities of tossing heads? Let's read these. The theoretical probability is greater than the experimental probability. Right now that's true because theoretically he should have gotten 10 out of 20 tosses that were heads. So the theoretical is more. The theoretical probability is less. That's false. The theoretical probability is equal. No, it's pretty close though. The theoretical probability is not related to the experimental probability. They're still related, so that's not true either. So the answer is F. And once again, he tossed a coin 20 times. Theoretically, 1 out of the 2 tosses would be heads. So if we scaled this up, it would be the same as 10 over 20. So out of 20 tosses, he should have gotten 10 heads. A number cube is rolled and a letter is selected from the word giraffe. Find each probability. So 15. The probability of 4 and F. So the probability of 4 on the number cube is 1 out of 6. And the probability of getting an F in that name would be 2 F's out of 7.
I have 1 out of 6.
So to solve this, we'll just multiply these. 1 times 2 is 2. 6 times 7 is 42. And then we could simplify this. This one we should simplify into 1/21. We just divided the 2 and the 42 by 2. All right, what's the probability of an even number? Well, there's 3 even numbers out of the 6 possible outcomes on the dice. A vowel, I see 3 vowels out of the 7. All right, so let's multiply these. 3 times 3 is 9. 6 times 7 is 42. And this one we will want to simplify again by dividing both of these by 3. And that gives me 3/14, which is our answer.